I ran over 6 tests to compare the RTX 5070 12GB of VRAM against the Intel Arc Pro B70 32GB of RAMs. Before we jump to the test numbers, let me remind you about these two cards. The RTX 5070 is worth around 700 euros dollars in the market, and it has 12GB of VRAM DDR7. While the Intel Arc Pro now 1,500 euros, and it has 32GB of VRAM DDR6. The memory bandwidth for the RTX 672GB per second, while the Intel is only 600.8 GB per second. The memory interface for the RTX 192-bit, while the Intel is 256-bit. The power is almost the same, 250 watt for the RTX and 230 for the Arc Pro B70. The cores are 48 for the RTX, while it's only 32 for the B70. For the first test, I'm using the Ornith 1.5 model, the 9B, and here is the numbers from the driver CUDA for the RTX, but also from the driver Vulkan. I'm using the llama.cpp, and therefore I could have different drivers for the RTX, while I'm using only the Vulkan for the Intel. For prompt processing, for 512 tokens, I got 3,600 tokens per second, and for prompt processing 8,192 tokens, I got a result of 3,525 tokens per second. Those numbers are lower on the Vulkan driver, and you can see it's almost, maybe I can say 10% difference here for the prompt processing. If we go to the token generation, for 256 tokens, it is scored 83 tokens per second, and for 4,096 tokens, it scored 82 tokens per second, which are really great numbers. Those numbers are getting a bit lower on the Vulkan driver, but still they are almost 3%, maybe 4 maximum percent for token generation. That's really great. For the Intel Vulkan driver, here there is a bit difference, and for the prompt processing 512 tokens, it is scored 2,200, or let's say 2,300 tokens per second, while on the 8,000 tokens, it is scored 1,621 tokens per second. Notice the difference here. In the prompt processing for the RTX, you can notice a drop down, while on the Intel, the drop down is really huge. Yeah, we are talking about 20 to 25% at least. And if we move to the token generation, for 256 tokens, it's a score 61. Here, it's score like 81 to 83, and for the token generation for 1,000 tokens, it's a score 56 tokens per second. And the utilization was around 97%, and it uses 6.9 GB of VRAM, and the temperature was around 70. For the Intel, 98% utilization, and 7 GB of RAM, and 77 degrees. I will show you the next test, which is using Gemma 4 12B. Prompt processing, 512 tokens, it is scored 3,245 tokens per second, which is really great. I'm happy about it. However, in Vulkan driver, we can see difference. While the Intel scored 1,650, so we are talking about half the speed actually here. For prompt processing with 8,000, it scored 2,954. There is almost a bit less than 10% drop down here. We can see it way bigger on the Intel, which is over 50% drop down when it came to the higher tokens for prompt processing. For 256 token generation, it's a score 74 tokens per second, while on the Intel only 50. So there is 50% being chopped out here. Anyway, for the RTX Vulkan driver, super close, 69 or almost 70 to 74 on CUDA driver. Token generation for 4,000 tokens, it's a score 71. Again, here we are really not seeing so much big difference or big drop down. And on the Intel is different story. It's scored 50 on 256 tokens. Here it scores only 38, which is almost a 30% of a drop down. For the third test, I used the Qwen 3.6 27B. It does not fit on the RTX. So therefore, I did another test for that with different layers assigned to the GPU, but I will show it to you a bit soon. For running solely on the GPU, the prompt to processing was around 59 for 512 tokens, and it was 44 for 1000 tokens. While on the Intel, here you can see a really big difference. It's scored 765 tokens per second and 750 for 1000. You might notice here the numbers are getting closer to each other's. For the token generation, 256 tokens, it is scored only 1.6, and for the Intel 25. And the Intel kept the same speed when we have 500 token generations, so scored also 25 tokens per second. And if I move a bit down to try the same test, but with different number of layers here, 20 layers on the GPU have a different score. Now we are scoring 461, and if I have the layers on 35 on the GPU, now the prompt processing is 589, comparing to the first one, which is only 59, almost 10 times the speed. For 1000 tokens prompt processing, we have 461 on the 20 layers, and on the 35 layers we have 575. For the token generation here, we can see from 1.6 earlier to 5.9 tokens per second, and on the 35 layers we have 8.1 tokens per second. Not big difference when it came to the 512 token generation. The fourth test, I run both of them on the Vulkan driver. The prompt to processing, the RTX was scoring 3600, the B70 was scoring 2200, and here combined together 2333. The 8000 prompt to processing, we have 3500 tokens per second, while half that on the Intel, and combined together we have them as 1900. For the token generation, we have it on the RTX 83 and the B70 is 61, while both of them have a speed of 66 tokens per second. We can see the numbers here and they make sense since the RTX only 12 GB, while we given the B70 32, so the 32 taking 3 shares of RTX 5070, and therefore we are seeing those numbers are way closer to B70. Here for this test, the numbers was for the RTX 3200 and for the B70 1600 together are 1800. We are talking on the Gemma 412B here. And for the token generation is also somehow the same pattern. We have 74 for the RTX, while we have 50 only for the B70. Together they scored 35. So combining together two GPUs on a small model does really not bring you big benefit, let's say, for now. But the story is different when it came to the Qwen 3.6 27B. Here the RTX couldn't handle it, of course, on itself, but anyway, the prompt processing was 59 for the RTX, while it was 765 for the Intel, and combined we are seeing 847. And for the token generation, RTX scored only 1.6 tokens per second, the B70 25, and here together 28. You can see somehow one big difference than the patterns we saw here earlier. Usually on the prompt processing, as much as the tokens increasing for the Intel, the speed it drops. Like as you can see for the Intel here, 1650 on 500 processing tokens. Here when it's 8000, it dropped almost to the half or even less than the half the speed. Here we can see something different. For the prompt processing for 500, it is 847, while on the 1000, which is, let's say, double the token, it's increasing the speed, which is 891. I tried this a few times and I saw this like kind of interesting. So I hope these numbers giving you an overview of the performance of the B70. The B70 really fall behind when it came to the software for now. It is not the easiest, let's say, GPU to set up. But I'm hoping there will be improvement when it comes to the software or the drivers in the soon future. I hope this video was helpful to some of you. In the next video, I'm going to have the RTX 4060 Ti Super, which is only 16 GB of RAM, but this GPU is no one talking about. While it's worth around $250 to $300/euros, it offers us 16 GB of VRAM, which is also CUDA driver compatible. Thank you for watching.